All right, so combinations of outcomes. How many possible outcomes are there? So in this video, we're going to talk about how to identify how many possible outcomes there are in a given situation, given your options. So first, let's talk about sample space. So sample space is the set of all possible outcomes. We show sample space by making a list or a tree diagram. Okay, and I'm going to show you both situations. First, let's look at an example. Cups of coffee example. So let's say you walk into a coffee shop. You look up and you see, well, you've got different types of coffee: standard, dark roast, light roast, decaf, half calf. I don't know who drinks this stuff. Sugar, none, regular, equal, Splenda, sweet and low. You look at milk, non-fat, low-fat, regular, half and half, or soy. And then coffee sizes are short, tall, grande, and venti. So as you're looking, you're probably thinking to yourself, well, probably not, but maybe you're thinking to yourself, how many possible outcomes are there? How many different types of coffee does this place make? Well, it's actually a really simple way to figure that out. First thing you're going to do is you're going to count. How many types of coffee are there? 1, 2, 3, 4, 5. How many sugar options are there? 1, 2, 3, 4, 5. Milk, 1, 2, 3, 4, 5. And let's assume you have to put milk in it. And then coffee size 1, 2, 3, 4. So we've got 5, 5, 5, and 4. What's the significance in that? Well, the counting principle says that we multiply the number of each option when all options are possible. Thus, the coffee problem results in us multiplying 5 times 4 times 5 times 5, which gives us 500 different combinations for 1 cup of coffee. 500. Look how small this list is. But there's 500 different combinations. Let's do this clothing example. So understanding what we did with the counting principle, where we multiplied the number of options, let's answer this question. If I have 3 different shirts, you guys talking about my closet all of a sudden? Red, blue, and green. 2 pairs of pants, black and gray. And you can either wear a hat or go hatless. How many outfits do I have? So remember, we only have 3 shirts, 2 pants, and the option of a hat or no hat. What do I do? That's right, you multiply them. Okay? 3 times 2 times 2. Now, if I want to look at my sample space and see exactly what I have in case I'm asking about the probability of wearing a certain outfit, this is what this looks like. Let's look at the first bullet point. I have 1, 2, 3, 4 different outfits. Red shirt, black pants, and a hat. Red shirt, black pants, no hat. Red shirt, gray pants, and a hat. Red shirt, gray pants, no hat. Same thing for blue and green, okay? Blue, black, and a hat. Blue, black, no hat. Blue shirt, gray pants, hat. Blue shirt, gray pants, no hat. And then green, black hat, green, black, no hat, green, gray hat, green, gray, no hat. So again, us listing this out, this is our sample space. Did you have to list it like this with bullet points and have them all put together like this? No. Okay, you could have put them all up individually. I just did this to save space. Again, this list is called a sample space. In this case, we have 3 times 2 times 2, which gives us 12 outfits in our sample space. And I can count that: 1, 2, 3, 4. This one has 4 and this one has 4. 4 times 3 is 12. I could have also, instead of listing this, done a tree diagram. If I did this, my tree diagram looks exactly like this. We start with shirts, red, blue, and green. We go into pants, black and gray. So if I had a red shirt, I could have black or gray pants, blue shirt, black or gray, green shirt, black or gray pants. And then, of course, from each set of pants, you'd go with whether you wear a hat or no hat. So where does the 12 come from in this case? Again, you are only counting the last row. Remember, row goes from left to right. Or if you want to look at it as branches, the last set of branches. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? There's 12 ends of our branches, or 12 different options in this bottom row. That tells us we have 12 different outfits. And I can use this, or I could use the list. The reason why I like the tree diagram better is I have less of a chance of forgetting a combination. If I list it this way, I might forget one of my combinations. Okay? So that's it for this lesson. We're going to be incorporating all of this probability into our worksheets and our work, and we're going to have a quiz soon. Okay?